Hello everyone. Welcome back again to the class of the database. In this video, we'll learn about the normalizations. So, the normalization is the technique or approach which used in both design, logical database, relational, so association, organization data with level dependency functional and which tell so that product structure that table normal. So the objective for normalization is minimizations, redundancy, repetition data, make it easy identification entity, prevent happen anomaly. A number of normal forms is we have the 1NF, 2NF, 3NF, and then base CNF. Yeah. Based on key and functional dependencies. If based on key and multi-value, we can use 4NF and 5NF. But in this material, we just learn about with 2BCNF. Okay, the first normal form is a 1NF, something relation called fulfill from normal first. If and only if every attribute from relation, the only on single value, and no there is repetition group attribute in line. From 1NF, no can contain group attribute which repeated. Objective from 1NF, semantic table become more explicit. Say anything once, all operator algebra relation can apply it to one table. For example, we have this table cells. We have table cells, and this called unnormalizations. Okay, this is not 1NF or a non-atomic. So let's see why this called unnormalizations. Because in the telephone, for example, cell's name is Yeni. Yeni have two telephones. Okay, had two telephone and with the comma in here. So this is not the normalization or the normal form, and we can make that and convert that to 1NF to like this. Okay, so if Yeni have two numbers, so we should change into this. Okay, so Yeni have number 1 and Yeni have number 2. Yeah, this is for normalizations 1NF. Okay, so 1NF for this this is have the once again the multiples or the redundance, but no problem, it's better than normalizations, yeah, because we can sort this data. So the others example is a table books. Okay, we have the table book here. So in this table we have the repeat table. Yeah, for example, we have the author ID and author name. Okay, in this same again, author ID and author name. This is normalizations. Okay, on a unnormalization form, so we can use this. Okay, for 1NF, so make that 1. Okay, so don't jangan biarkan or don't this rows is null. Okay, so it should be filled. Okay, so until we can convert into the 1NF, so the second one is second normal form or 2NF. Something relation called fulfill from a normal second if and only if we have the fulfill 1NF. Okay, and the second, every attribute which no key main depends in a y functional to all attribute key and no only part attribute key, fully functional dependent. For normalization to form 2NF, so table 1NF decompose becomes several table which each fulfill 2NF. For example, we have the tables and the relation A, B, C, D, E for the attribute. Okay, we have the attribute A, B is key main, yeah, or primary key, and for reasons or the dependence, AB is to CDE. Okay, then table L fulfill N to NF because AB is CDE, means AB to C, AB to D, and AB to E. So all attribute no key means dependent full and AB. Okay, so how when are ABCD but with the FD or dependence AB to CD or B to E is equal to NF? Yeah, where that are no to NF because there is attribute E which dependent only one attribute B and A and no to AB. Okay, for example, this we have the workshops tables. Okay, for name, module, cost, and grade. For example, we have the name, module, course, and grade. So we have name and module. This for primary, especially for this have two primary key. Okay, but not primary key is number one is candidate key. Okay, and name is the primary key. But this is for the dependence. Okay, so be dependent. As we know, module is dependent to the course. Okay, module is dependent to the course. Course determined by module taken student. Okay, like course determined by module taken the student. So table course participant workshop like this, for example. Okay, so the cost is not dependent to the name. Okay, because cost is determined, sorry, cost not determined to the name atau nggak bergantung pada name gitu ya, but cost is determined to the module ya, costnya tergantung pada modul. Jadi if this cost is 24,000 ya, is for VBNet. Okay, and prologue is 1. Okay, its prologue is 1, LP is 6 every minute. Okay, now this is 1NF. Okay, 1NF fulfill. Okay, because we not have the more value in the attribute. Okay, in the one attribute, so this is not to NF because in table this cost not dependent full on attribute key. Okay, cost is should be dependent to module, in cost should be dependent to name, but this is not dependent. Okay, because cost is dependent just to module, not to name. Okay, so like this, module dependent to cost, and a name and module is should be dependent to cost and grade. So how? Cost we will eliminate. Okay, cost we will eliminate and make the composites for two tables, and the works one is will be name, module, and grade. Okay, but we not have the cost in the works in the table 1. In the works 2 or table 2 is have the module and cost, so fully dependent. Okay, so before it's like this workshop, and we can split or the decomposite into two table. Okay, because yeah, cost is not dependent to the module. So we have the table 1 or works 1 is name, module, and grade. So the works 2 or table 2 is we have the module and cost. Okay, number 3 is true normal from or 3NF. Something relation can fulfill from normal 3NF if only if is the fulfill to NF. Okay, so number 2, if every attribute which no key, no dependence in a way functional to attribute is not key which other in relationship. No, there is dependence transitive on attribute no key, or something relation called fulfill from normal trade if only if every not triple FD. Okay, or determinants x to implication A in where x and A is attributes. Okay, for example, we need the example for trade. Okay, so this is the compositions. Okay, so the A, B, C, and D, so we have the relation. Okay, or we have the two tables or sample like this. Sample is no information structure from something supplier documents. So we have the number supplier, we have the status, we have the city, we have the pk, okay, we have the p and quantity. We form something table with the tps scheme. Okay, we have the s, status, city, p, and kita. So with sp is the primary key or and the candidate key, and applied to determinant is s to the s, status, yeah, to the city, city to the status. Do normalization from 1 nf up to 3 nf. So the first one, we have the 1 nf here. Okay, so we not have the null attribute, so not to nf because the problem is redundancy, inconsistency, low speed. Okay, anomalies, s is status from city, or s is dependent to or determinant to status of the city, but the p is not determinant to the s. Okay, so just key quality to determinant to the p. Okay, solution is make the compositions or split into the two tables. Okay, we have the table TPS ones is status, S status and city, and TPS2 is SPQT. Okay, and the TPS2 is we have the 1NF, 2NF, and 3NF. Okay, redundancy partial, but not possible remove all redundant, but do it reach minimum. And the TPS1 is not 3NF. Okay, it's not fulfilled, but 1NF and 2NF is fulfilled. 3NF because as the city, yeah, city or status. So now we can add the data S530 and Jakarta in the way safe, but still there is anomaly because city is dependent or determinant to the status, so we can entry data city new before status have marked. Removal one partial row data city also can destroy integrity information. Okay, for example, so we can use like this as okay, s1 we have the city. Okay, we have until 3NF, and we have the two table against the city and the status, and TPS2 is we have like this. Okay, so now is BCNF or Boyd's code normal form. Something relation called full BCNF if only if every determinant which there is on relation the there is a candidate key. Definition which other something relation called fulfill BCNF if for every determinant non-trivial x implication a attribute x is super key. So we can see the example. For example, we have the student tables, we have the books, and we have the borrows. Okay, student is we have the SID, name, age. Okay, we have determinants is SID for name and age. Okay, BCNF is because SID is super key, and the books is BCNF. Okay, because bit is super key. Okay, from the title and years, but the borrows SID bit that. Okay, for example, this loan ID is just to bit and that, no BCNF because loan ID no super key to the ID borrow, or SID here. It's not determinants. So the solution is we should be decomposition. Okay, decompose become the borrow one, loan ID. Okay, this will be BCNF, and borrow 2. Okay, ID data super key. Okay, so it should be super key. Okay, comparison between BCNF and 3NF that always for parse something relation in 3NF, and its decomposition is lossless, dependencies maintained. Okay, but for BCNF is its decomposition is lossless too, no possible maintain dependence. Okay, that's for example not BCNF or BCNF. If we have the 3NF, for example, any module and lectures, but in the BCNF the lectures, okay, it should be uh, decomposed, okay, or make the new tables in here. Okay, thank you very much guys for watching this video, and don't forget to um, quiz and check the assignment. Thank you very much.